In this lab, we're going to take a look at the stoichiometry involved in an acid-base reaction. So here we're pouring an acid solution as well as a base solution together into a styrofoam cup. And what we'll be doing is measuring how the temperature changes based on the volumes of acid and base that are added. Inside the cup, we have a stir bar and a thermometer that is sending temperature data to a computer. As the acid and base mix together, we can see that the temperature slowly starts to increase. At some point, the temperature will plateau and it will no longer increase regardless of how long we let the reaction go. So we can sit here and watch the first example as the temperature starts to increase to about just over 25 degrees Celsius from around 24 degrees Celsius. We've sped this up here for time purposes. Here's the data for experiment number 1. You can pause the screen here and copy the data down into your favorite spreadsheet program or into Desmos for use later. Once you have all that data, I want you to plot a graph of volume of the base versus the change in temperature by hand. Draw a line of best fit to the first 3 points and draw a separate line of best fit to the last 3 points. Use those lines of best fit to determine the volume of NaOH at the point of intersection. Using that volume, determine the volume of acid. Find the ratio of the volume of the base to the volume of acid, and then write a balanced chemical equation and compare the value you got for the ratio of volumes to the molar ratios you're going to get. Here's the data for experiment 2. And again, you can pause the screen here to copy this down if you need to. With this data, you're going to plot the graph again, but this time I want you to do it in Desmos. You're going to again draw a line of best fit through the first 3 and then through the second 3 points. The point of intersection, just like the first time, is going to be the volume of NaOH you're going to use that gives you the maximum temperature, and use that volume to determine the volume of acid that would be required. Find the ratio of the volume of the base to the acid again, write a balanced chemical equation, and just like in experiment 1, compare the 2 values of the molar ratio and the volume ratio. For experiment 3, we've changed to using potassium hydroxide. Again, you can pause the video here and copy down this table. Plot the volume of the base versus change in temperature however you would like. Draw a line of best fit to the first 3 points and the last 3 points, and this time determine an equation for that line. Algebraically, solve the system of equations, and that point of intersection will give you the volume of potassium hydroxide. Using that volume, find the volume of the acid that will give you the maximum temperature. And once again, use the ratio of the volumes and compare that to the ratio of the moles in the balanced chemical equation. In general, what is the relationship between the volume and the molar ratios of the acids and the bases? Consider the reaction between magnesium hydroxide, a base, and citric acid, the acid used in experiment number 3. Based on what you know, what volume of each solution will produce the largest change in temperature?